Thank you very much, and thank you all for coming along today. It's great to see so many of you. I guess databases are things that are quite often considered difficult to test or difficult to get any insight into, and quite often there's a lot of code, a lot of logic in databases where perhaps it shouldn't be. So I'm going to talk to you today about how we can get some insight into what is in the database in terms of logic and how we can test that as well. So my name is Alastair Smith. I'm a former developer at Redgate and now working for a startup called CloudHub 360. We do smart document classification in the cloud, lots of buzzwords like machine learning and cloud and that sort of thing. So an application developer primarily. My forte, I guess, is C# and application side programming languages. SQL and T-SQL not so much, so please forgive any errors that I make in the demos later on. The demos that I've got are all based on open source software. Primarily I'll be using T-SQL-T, which is a unit testing framework for Microsoft SQL Server. The demos themselves are written against SQL Server 2014, but the concepts are really applicable to any RDBMS at all. You can find unit testing frameworks for many other RDBMSs on testanything.org, and if you're an Oracle SQL developer, then you'll find unit testing features built right into their IDE. A quick show of hands, how many of you are SQL Server users, developers, etc.? About half. Okay. Oracle? Okay, about a quarter. MySQL? Postgres? Okay, cool. That's just to help me kind of tailor how much detail to go into in the demos. So a little bit more about my background. I'm an active member of the software craftsmanship movement, hence the kind of test driving bit, I guess, and have been since 2010 when I first encountered the movement, and founded the Cambridge Software Craftsmanship community in 2012. There is a software craftsmanship Slack channel. If you haven't got enough Slack channels already, then do sign up to ours at the bottom there. There's lots of really interesting conversations going on there, and we're a very friendly community as well. And if you haven't yet encountered the Socrates Unconference events, then do kind of Google those. There's one taking place in the Canary Islands next week. There's one in London. No, not in London. In Surrey, that's it. In sort of mid-June. They take place all over Europe, essentially, across the year. So, yeah, do try to get to one of those for fantastic conversations about software craftsmanship, continuous delivery, anything on your radar, really. Right, let's talk about testing and unit testing. So why should we bother unit testing our database? Why do we test our applications?
To make sure they work.
Yep, that's a very good starting point. What else?
Be able to refactor it?
Yep.
To blame people.
Ooh, that's a bit controversial. Yeah, so we can test our databases for the same reasons, to find out early on whether there are bugs in the database, to get confidence to refactor. For me, one of the key benefits of unit tests and test-driven development as a process is the concept of verifiable documentation. You end up with this test suite that gives you a bunch of green ticks against everything that the system is supposed to do. And when you've got all of those green ticks in place, you know you're done because the system is passing all of the tests. How many of you are familiar with the process of test-driven development? Great, okay, I'll skip over that then. And let's get straight into some demos. Right, so let's see if this works. Yes, excellent. Right, so as I say, T-SQLT is an open source project. It's downloadable from SourceForge. It is not dead. In spite of that, it's still under active development. There are a couple of things that we need to do to get T-SQLT set up. The first one is to enable the SQL CLR. There is a massive security hole in SQL Server with the SQL CLR enabled, so don't do this on your production servers, whatever you do, and keep these servers well off the internet and every other form of connection. Yeah, so there's a bunch of logic that T-SQLT relies on to get the assertions and the faking of tables and things working in SQL Server that all happens inside .NET Assembly in the SQL Server process. So we start off by running this little script that you get from the T-SQLT zip file when you download it, and this just enables the SQL CLR and kind of reconfigures it essentially to say that it's on. And then we have a very long script to install T-SQLT itself. Luckily, I've already done this, so we can take a look at the stored procedures in this database. And we can see that we've got a whole bunch of T-SQLT namespaced stored procedures in place, things like assert empty table, assert equal, etc. So I've skipped over a little bit. T-SQLT is a unit testing framework for SQL Server. Not only does it give you the standard unit testing framework, things like test suites and test methods and assertions and that sort of thing, it also takes the responsibility of things like mocking tools. So you can fake a table with T-SQLT. Rather than writing against a specific concrete table in the database. The other thing that I've skipped over is this Chinook database, which is just a very simple sample database. It's a really handy kind of example for talks and application development and what have you. It models a music store system. So we have albums, we have artists, and we have employees and customers and playlists and all that sort of thing. It's an online music store. You can download it for free off Codeplex, I think. So that is T-SQLT and Chinook. So we now want to make sure that this is all set up properly. So we can do this, first of all, by creating a new test class. And we will call this simply, does it work? So a test class is equivalent to a test fixture in application unit testing frameworks like JUnit, etc. And that completed successfully, and if we, no, that won't show up yet. We now need to create our procedure, which is going to be our actual unit test. So does it work? Test T-SQLT works properly. Oops. And we'll get rid of this junk. And again, create table. No, actually we don't need to do any of that. We can just say exec T-SQLT dot set equals expected true, actual true. Right, whoa, don't do that. And if we execute that script, that should have created us a new stored procedure called does it work? Yes. Let's just expand this. There we go. So test T-SQLT works properly. And if we now execute that test using run all, we should have, yes, we have a passing test. Excellent. True equals true. Who knew? So we now know that's working okay. We can do another quick test that is, does it work? Test table structure is correct. So in the database, as I said, we have a table called album, and we happen to know that in that album there are 3 columns. There's the primary key album ID, there's the title, and there's the artist ID. So sometimes what you might want to do is verify that the shape of your table matches what you expect. So if you are interacting with the tables directly, then you may want to verify at the database level that the application is going to get back what it is expecting. And the way that we do that is by creating a temporary table called .expected, and that has an album ID, which is an int, which is the identity, and it's not null. Have the title, which is an varchar of 160, not null. And we have the artist ID, which is also not null. And then we write our assertion, which is asserting results sets have same metadata. So this assertion looks at the metadata of the table that is returned by the expected command and the table that is returned by the actual command, and compares the structure of those and various other things like whether the columns are null and primary key, etc. So the expected command here is select star from dbo.album.expected, and the actual command is select star from dbo.album. So we're comparing the structure of the temporary table that we've just created with that of the real table in the database. And we close that off, hit F5, and no mistakes. Excellent. Oh, thank you, mouse. So again, we should see another one here. Yes, we do. And if we do exec t is equal t dot run all again, then oh, failed. Okay. Two. DBO album dot expected. Okay, I think that's right. Let's try that again. Yes, there we go. Cool. So we've got 2 passing tests now. Right, so back to the slides for a moment. Oops. Please don't crash again. Okay, I've got both on that one monitor now. That's Okay, there we go. Right, so some sort of recommendations and anti-recommendations of things to test. So do test the behavior of your database. Much like your application code, test the behavior rather than the data, because that's the thing that changes. It's also the interesting bit of the application, the operations on the data. So do test the stored procedures, the functions, the triggers, views, constraints, and maybe even sort of coding standards and things if you want on your database. I would generally recommend not writing tests like the one that I just wrote to test the object structure, because this can lead to very brittle tests. If you change the structure of your table, then the test is going to instantly break, and you're going to have to keep that test up to date in line with the table that you have in the database as well. It's a bit like testing your DTOs, I guess, in the application sense, data transfer objects. And that, yeah, as I said earlier, I can see reasons for wanting to do that because it's an external system, but personally, I probably wouldn't myself. Right. Next slide. Yes, so let's look at testing stored procedures and constraints. Okay, so as I said, in the database we have albums and we have artists, and let's say that we have a feature coming in from the product manager or whoever that says we want to be able to access all of the albums released by an artist from the artist's page. So a user wants to be able to view everything that an artist has put out at any point. And for performance reasons, we want to push this into the database so that we can take advantage of the benefits of compiling the stored procedure, etc. We have the album and we have the artist. They're both very simple tables, very little data in them, but there's that crucial join between the two that says which album was put out by which artist. We also happen to know, based on the data that we have in our sort of copy of our production database, that we have some very specific albums in here that we can test for, that we can use as test data. So somewhere in this long list, you'll probably find Use Your Illusion 1, Use Your Illusion 2, Appetite for Destruction, all Guns N' Roses albums. So we can use that as our test data. So we can do that by, first of all, creating a new test fixture, which we'll call artist releases. So that's now completed, and we are here to learn about test driving your database. So let's apply a bit of test-driven development to this process. So we want to call this artist releases. Is that what I just called it? Yes, cool. And we'll say test albums for artist by name returns the albums for the given artist. So very descriptive test name to indicate that we've got an item of specification here that we're filling in. So add those, and again, because we're test driving this change, we're going to start off by writing our assertion for the test. So that looks like set equals table. We have we're going to create a temporary table called expected, and we're going to save the results from our actual table into a temporary table called actual. And we'll delete that because no one uses the failure messages anyway. Okay, so that's the actual assertion statement that we want to execute here. The way that we get to that is slightly convoluted. So we have an actual table, which is just an album title, which will be a varchar, and we want to insert into that Guns, let's get the escaping right, Guns N' Roses, and we want to create the temporary table for expected, which is going to be very similar, oddly enough, to that. I've missed semicolons everywhere, so that's probably going to blow up. Get rid of that as well. Okay. And finally, we want to insert into the album title appetite for destruction. Oh. Use your illusion 1 and use your illusion 2. Right, cross your fingers. Okay, that seems to have worked. It's more confident than I am. Okay, awesome. So this is an indication that the test is failing. What we have here is a really nice feature of T-SQL-T, which indicates the differences between the expected and the actual tables. So what we have is the expected table contains everything that we asked for, plus, no, sorry, and the actual table, for some reason, has Guns N' Roses in it. But what we've not done at any point is actually write the code for this stored procedure. So let's go ahead and do that, which is albums for artist by name. The artist name is another string. And let's start off by saying we will just return the album title and let's just double check that I got that insert statement right. A bit premature. No, I didn't. Okay. Exec dbo.albums for artist by name. The artist name equals Guns N' Roses. That's why it was appearing in the results. Okay. Okay. And just alter that. Okay. So, if we...
Does it have to be an int?
Oh. Yep, we can just delete that, I think. So, Sequel T, run all. Oh. Okay, so we can now see that we've got the 3 rows that we expected, but we've also got a bunch of extra ones that we don't expect in the results. So we'll go through and add the necessary join and restriction to complete that. Artist on here, album, artist ID, DVO, artist ID, DVO, artist name, artist name. Alter that. Run again, and hey presto, we have matching data sets. I'm very short on time, so I won't do the final demo on constraints, but there is a very confusing aspect to testing constraints, which is that you need to test the failure mode of the constraint. You can't test it for success. And the way that this works is you create a fake table that matches the structure of the real table and selectively apply the one constraint that you wish to test, and then attempt to violate it, trap the error that it then inevitably throws, and assert that the error was thrown. Yeah, as I say, it's a bit convoluted. I have a worksheet that goes through all of the demos that you've seen, plus a couple more, which you can sort of work through and follow on at home or in the office tomorrow or whatever, as you wish. So I'll tweet the link to that afterwards. That is, I think, pretty much it. There's, oh yeah, there's a nice illustration of the test data builder pattern. How many of you are familiar with that? No hands. Wow. Okay, more of you need to be aware of this. Growing Object-Oriented Software Guided by Tests. A fantastic book on unit testing and acceptance test-driven development by Steve Freeman and Nat Price. One of the best software books I've read. Absolutely worth your time reading it. One of the patterns that they recommend in there is, rather than creating a customer object in this example and calling the customer constructor directly with all of this information that it requires, create a builder for it, because what you will inevitably find, if I can scroll, come on PowerPoint, don't do this to me. What you will inevitably find is that the test that you are writing probably doesn't care about half of the information that you provide to the customer constructor. So what we have here is a simple factory method that returns an instance of a customer builder, and then these 3 methods are all defined on customer builder to override default values for a given customer object, and the build method converts or creates an instance of the customer object based on the data that you've provided. It makes the test much more readable than the previous version, because it only includes the data that we're interested in for that test. You can do something very similar in SQL using default named parameters, essentially, in T-SQL-T. What is left? Yes, you can run your tests on your CI server as well. There's a T-SQL-T runner for Team City that works pretty nicely. It's pretty easy to set up and configure. Don't forget to deploy your database, deploy your tests, and any additional code that you need to write, and be careful passing the options to SQL CMD, depending on what you've provided. in your scripts, because that caught me out when I was putting together the demos. Also, if you want to do this kind of more solidly and robustly, then Redgate have some fantastic tools for automating database deployment and general change management. That is, I think, about out of time.